I'm going to create the circuit given on the Multisim instruction sheet. I'm just going to recreate that here in Multisims. It's pretty simple. All we have is we have a DC voltage source that we're just going to put right here. Then we have two resistors, one that is in series with the DC voltage source, and two that are in parallel with each other there, along with a ground connection so that we can get the negative portion of the voltage source to equal 0 just to make everything easier. So now we're just going to connect. Oh, forgot to. Oh, that's disgusting. Okay, so we gotta flip around these resistances just so it's easier to connect them in parallel. That one connects there. This one connects to this resistor. This connects to here. And we got the ground connection just on that line. And finally connecting up the last resistor. Now, so I just picked some arbitrary real life values that would give me somewhere within the range of 0.5 and 0.8 amps. So I picked 100 volts just because it's a nice number and I like it. So we have 100 volts. And then I have a resistor of 100 ohms. And then I have these two parallel resistors are both 150 ohms, just so that the math is easier and I don't have to do a lot. You just got to prove that I can get this to be 0.5, to be somewhere between 0.5 and 0.8 amps. Now, if I would run this, nothing would show because it can't detect any graphical data. So essentially, we got to grab like these little probes and stick them on the current, on like the loop, because it acts as a multimeter. So I'm just going to grab the current and voltage one just because it's giving me twice the data and I don't have to use as much. Put one at the beginning of the loop, one at the end of the loop, and then we'll put one right before the split and right after the split, just so we can get more data there. And as you can see the voltage drop as we go through. So it's going to drop to 0 there, which it should. That's exactly what I'm expecting. Now, if I run this, I should get between 0.5 and 0.8 amps. And rerun it. Oh, that's a problem. Yeah, that says negative amps because the probe, as you can see, it measures a certain direction, so it's measuring this way when the current's going clockwise instead of counterclockwise. So we just double tap on that, flip it, bam. Okay, there we go. So we should now read, 571.43 milliamps. Now that's exactly what I got for my theoretical calculations. So you just gotta multiply that, I think, by 100. 571, you divide that by 1,000, and I'll give you 0.571, so that's 0.571 amps, which is in between 0.5 and 0.8, and according to my theoretical calculations, I got 0.5714, so that's pretty much the exact theoretical number I got. I can throw up on screen the little work I did on the sheets to show that I actually got that theoretically. But there you go. That's a little multi-sims. Pretty nice to just throw up a circuit if you just want to test it without actually making the circuit. That's it.